So very good morning. Welcome back, friends. In module 3 yesterday we discussed on the measurement of pressure. In fact, we introduced the principle of manometers, the types of manometers, the classification of manometers as simple manometers and differential manometers. So simple manometers, it measures the pressure in a vessel containing a liquid or a fluid, or it measures the pressure even in a pipeline wherein the fluid flows. Then we discussed on piezometers, the simplest form of manometer we come across, and what are its merits and demerits, what magnitude of pressure it can measure. It can measure only moderate pressures. It cannot be used for measuring high pressures of lighter liquids particularly, and also it cannot measure the pressure difference. Then we discussed on U-tube manometers and manometric liquids. What are the manometric liquids which are commonly used in manometers? So now, and we worked out some sample problems involving piezometer as well as manometers. And in this module, we will be discussing on the differential manometers, the second type of manometers. And differential manometers are those manometers which are employed for measuring the pressure difference between any 2 points in a pipeline or in 2 pipes or containers. So the construction, the basic construction or the fundamental construction of a differential manometer is that it consists of a bent glass tube, the 2 ends of which are connected to the gauge points between which the pressure difference is required to be measured. So the common types of differential manometers are 2 piezometer manometer, inverted U-tube manometer, U-tube differential manometer, micromanometers. Of course, micromanometers we will not be discussing. We will be discussing the first 3 which are very commonly employed. In fact, the second and third are very commonly employed. So anyhow, let us discuss the first 3 in depth and also work out sample problems involving these 3 types of differential manometers. So the first one is 2 piezometer manometer. It consists of 2 separate piezometers. So piezometers we discussed in the previous module as the simplest form of manometer, which can be used to measure the pressure at the gauge point. So this consists of 2 separate piezometers. So this is one piezometer, this is another piezometer, so 2 separate piezometers. They are inserted at the 2 gauge points. So A is one gauge point, B is another gauge point. In fact, I want to measure the difference in pressure between the 2 gauge points A and B, between which the pressure difference is to be measured. So it consists of 2 separate piezometers inserted at the 2 gauge points between which the pressure difference is to be measured. So what happens? Say for example, this is a pipeline. This is a pipeline conveying a fluid of some specific weight, gamma. So it is moving in this direction from A to B. And what happens? So we will see when we discuss on flow through pipes, the flow always occurs from high pressure to low pressure. So as the flow direction is A to B, the pressure at A will be higher than the pressure at B. So this we will be establishing when we discuss on flow through pipes later in fluid mechanics. So here, because of the pressure at A, the pressure is transmitted in the form of rise of liquid which is flowing through the pipeline to a height HA. There is a rise of liquid in the piezometer. So here please note, the 2 piezometer manometer can be used to measure only difference of pressure in which liquids are involved. We cannot measure gases because gases do not have a free surface. And similarly, because of the pressure at B, fluid pressure at B or the liquid pressure at B, the liquid rises in the piezometer connected to point B to a height HB. So HB will always be less than HA because the flow direction is from A to B. So this difference in levels of liquid in the two piezometers, the difference in levels of the free surfaces in the two piezometers, that is H is equal to HA minus HB. So this gives the difference in pressure head, between the gauge points A and B. So figure shows the schematic arrangement of two piezometer manometer for measuring pressure difference between 2 points in a pipeline. The pipeline conveys a liquid of certain specific weight. It is required to measure the pressure difference between the points A and B in the pipeline. So two piezometers are connected, one to the gauge point A and the other to the gauge point B. The flow direction in the pipeline is from A to B. So HA and HB are the respective heights to which the liquid has raised in the piezometers at points A and B respectively. So HA and HB indicate what? The pressure head. The pressures at points A and B in equivalent column of the flowing liquid. Now the pressure difference in equivalent column of flowing liquid between points A and B is simply the difference between HA and HB. This is what I explained. So for learners, please don't be carried away by the paragraphs I have written. So it's all self-explanatory. So I have put it in the form of lecture notes. So whatever I am explaining, it is given in the form of statement. Therefore, you will find it very easy. Don't assume that it is too big, right? Only simple concepts have been broken into very simple statements and explained in such a way that you can understand very easily, and you can just go through the notes as you are reading a storybook. So this method, what are the demerits? So like we discussed the demerits in piezometer. Here the demerits is that it is useful only if the pressure of the two gauge points are small. So piezometers we discussed, they are used for measuring only moderate pressures. They cannot be used for measuring high pressures of lighter liquids particularly. So when the pressure difference is small between the gauge points, then you can use this two piezometer manometer. If the magnitudes of pressures are high, it requires long piezometers and it becomes inconvenient to measure the pressure difference. Then, as I said, it can be used only for measuring the pressure differences in gases, in flow of liquids, not in flow of gases. So you cannot use a two piezometer manometer for measuring pressure difference in flow of gases through a pipe. Then inverted U-tube manometer, the second category. It consists of a glass tube bent in U shape and held inverted as shown in figure. See, like this. So inverted U. So what does U tube means? It is the alphabet U. Inverted U tube means it becomes like this. So this again, you consider this as a pipeline, this as a pipeline, which is conveying a liquid again in this direction, that is A to B. So pressure at A will be higher than pressure at B. PA will be greater than PB as the flow direction is from A to B. See what happens, there is no manometric fluid involved in this, so only air is present. So depending upon the pressure at A, the pressure transmission occurs by rise of liquid in the left limb connected to gauge point A. Similarly, because of the pressure at B, the pressure will be transmitted by rise of liquid in the right limb of the manometer at B. Then because of the pressure difference, there is a difference in the level of liquid surface in the left limb as well as the right limb. This is D. The two ends of the manometer are connected to the points A and B in the pipeline between which the pressure difference is required to be measured. So when flow occurs in the pipeline, because of the pressure prevailing at points A and B, liquid will rise in the two limbs of the manometer, thereby pushing the air in the manometer to go up and get compressed. The compressed air restricts the heights of columns of liquid raised in the two limbs of the manometer. So an air cock, this is the air cock, right? Air cock. So what is the purpose of providing an air cock? The air cock is provided where at the top of the inverted U tube, which facilitates the rise of liquid in the two limbs to suitable levels by driving out a portion of the compressed air. The air cock also allows the expulsion of air bubbles that might have been entrapped in the pipeline, so that there is no differential differential column due to the air entrapped. The air entrapped must be released, right? So let PA and PB be the pressure intensities at the points A and B. So corresponding to the intensities of pressure at these 2 points, the liquid will rise above the points A and B up to points C and D. So the pressure at A is transmitted by way of rise of liquid in left limb up to point C. Similarly, the pressure at B is transmitted by way of rise of liquid at B up to D. So D is the surface of liquid. In the two limbs of the inverted U tube manometer. So if S is the specific gravity of the liquid flowing in the pipeline and gamma W is the specific weight of water, then you can develop the manometric equation, that is the pressure equation commencing from point A. So let us start from A and go along the manometer, left limb and then right limb, and come back to point B. So let us go step by step. So let us express the pressures at various points in equivalent columns of flowing liquid. So here we are writing in equivalent column of the flowing liquid of specific weight gamma or specific gravity S. So what is pressure head at A? Pressure head at A will be PA by gamma W into S. So pressure head at A will be PA by gamma WS. So we know the fundamental pressure equation is P is equal to gamma H. This is the general expression. So P is the pressure intensity in Newton per meter square. Gamma is the specific weight of the flowing liquid, say in Newton per meter cube, and H is the pressure head, equivalent pressure head in pressure head in equivalent column of the liquid of specific weight gamma. So what is H? H is equal to P by gamma. So PA is the pressure intensity at A Newton per meter square. Gamma is the specific weight of liquid or fluid that is flowing in the pipeline, which can be expressed as gamma W into S, where gamma W is the specific weight of water and S is the specific gravity of the flowing liquid. So PA by gamma WS, meters of flowing liquid or specific gravity S. Then we go to C. C is another point which marks the surface of liquid in the left limb. So what is pressure here at C? So from A you are going up. So when you are going up in elevation, the pressure decreases. What? At the constant rate of specific weight of the liquid of specific gravity S here. So pressure head at C will be pressure head at A in meters of liquid of specific gravity S minus HA meters of liquid. So HA is what? HA is only liquid of specific weight S, therefore you can simply put HA. So PA by gamma WS minus HA. Then C, we are taking another point E in the right limb such that E is in the same horizontal plane as that of C. So C and E are at the same elevation. So because they are in the same plane, so the pressure does not vary in the same horizontal plane, it remains the same. So pressure head at E will be equal to pressure head at C. So pressure head at E is equal to pressure head at C, since both points C and E lie in the same horizontal plane. So pressure head at E will be again PA by gamma WS minus HA. Then you are coming down to D. What is D? D is the surface of liquid in the right limb. So at how much vertical distance D is from E? It is H meters below E. So pressure head when you are going down, that is when the elevation decreases or when the depth increases, the pressure increases. So pressure head at D will be pressure head at E plus pressure head due to column of air. It is, what is that you have in between E and D? It is only air. So head due to column of air in the portion ED of the right limb of the manometer. Now as the pressure exerted by column of air is negligible, so if you take the weight density or specific weight of air, it is very, very less. So let us ignore that. So let us ignore the pressure exerted by column of air due to its low specific weight. So pressure head at D will be equal to pressure head at E. So pressure head at D will be equal to pressure head at E then you are coming down to B. So, pressure head at B will be pressure head at D plus HB meters of liquid or specific gravity S. So, what is HB? HB is equal to HA minus H. HB is equal to HB is equal to HA minus H from figure. So, pressure at B is equal to PA by gamma WS minus HA plus HB you replace as HA minus H. So, this HA and this HA will get cancelled with each other. So, you have PB by gamma WS is equal to PA by gamma WS minus H. So, PA by gamma WS minus PB by gamma WS is equal to H meters of liquid as specific gravity S. So, the difference in pressure head between the gauge points A and B is nothing but H meters of liquid or specific gravity S, which you can directly observe from the manometer deflection. What about the applicability of inverted U-tube manometers? They are used for measurement of small difference of pressures of liquids, small difference of pressures of liquids. So, let us solve an example under this category, inverted U-tube manometer. The pressure between 2 points M and N in a pipeline conveying oil of specific gravity 0.9 is measured by an inverted U-tube, and the column connected to the point N, which is the downstream point, is 1.5 meters higher than that at point M. So, please note the column connected to point N, that is the right limb, is 1.5 meters higher than that at point M. So, the level of liquid in the right limb, which is connected to N, that is at C, is higher than the level of liquid connected to point M in the left limb, that is B, sorry, this one, this point. So, 1.5. So, a commercial pressure gauge directly attached to the point at M reads 2 kgf per centimeter square. Determine the reading of the gauge when directly attached to the pipe at N. So, this is the statement given, and we have to draw this sketch. So, schematic representation of the problem statement. What is required? It is required to determine the reading of the commercial pressure gauge when directly attached to the point. So, instead of inverted U-tube manometer, if you have a pressure gauge here at N, what is the reading indicated by this pressure gauge? We have to find out. So, let us express again the pressures at all points in equivalent column of the flowing fluid, which is oil of specific gravity 0.9. So, let us again write the manometric equation in gauge units. What is gauge units? That means you are taking the atmospheric pressure as the datum. So, let the pressure intensity in gauge units at point M be Pm. The pressure head at point M in equivalent column of oil is expressed as Pm by specific weight of oil which is flowing in the pipeline. So, gamma oil is the specific weight of oil which is equal to 0.9, that is specific gravity of oil multiplied by specific weight of the standard liquid, that is water, 9810 Newton per meter cube. So, you get 8829 Newton per meter cube as the specific weight of oil. Now, pressure head at A in meters of pressure head at A in meters of oil, pressure head at M minus Y, that is this is A, say this is A, that is the surface of liquid in the left limb is at A. So, that is missing in the sketch, you please mark it A. So, pressure head at A, so A is above M. So, pressure at A will be less than pressure at M. So, what is the pressure head at A in meters of oil or specific gravity 0.9? So, there is pressure head at M minus the difference between M and A is Y. So, what is it you have? Y column of only the same liquid of specific gravity 0.9. So, Pm by oil minus Y. Then pressure head at B. Where is B? B is a point in the left limb such that it is in line with C, which marks the surface of liquid in the right limb. So, Pb. So, pressure head at B. So, pressure head at B will be pressure head at A minus 1.5 meters of air expressed in equivalent column of oil or specific gravity 0.9. It is. So, pressure head at B will be less than pressure head at A, that is PB is less than PA because B is above A. So, what is pressure head at B? Pressure head at B is equal to pressure head at A minus 1.5 meters of air column between A and B, which has to be converted into equivalent column of oil or specific gravity 0.9, because we are expressing all pressure in terms of equivalent columns of oil or specific gravity 0.9, which is flowing through the pipeline. Now again, as the column of air can be neglected because air has got a negligible specific weight, and therefore the pressure also due to the air column between A and B is negligible. So this can be neglected, this can be ignored, this can be ignored, this can be ignored. So pressure head at B becomes pressure head at A, which is nothing but Pm by gamma oil minus Y. Then we move to C, C in the right limb. Where is C? C is in the same horizontal plane as that of B, they are in the same elevation. Therefore, pressure head at C is nothing but pressure head at B, which is Pm by gamma oil minus Y, as both points B and C lie in the same horizontal plane. Then we come down to N, pressure head at N, N is below C, so Pn will be greater than Pc. By how much? Will be higher, pressure head at N will be higher than pressure head at C by 1.5 meters plus Y meters of column of liquid or specific gravity 0.9. So pressure head at N is equal to pressure head at C plus 1.5 meters plus Y meters. So pressure head at C is nothing but Pm by gamma oil minus Y plus 1.5 plus Y. So Pm is given as 2 kgf per centimeter square in the problem statement. So converted Newton per meter square, 1 kilogram force is 9.81 newtons. 1 centimeter square is 10 power minus 4 meter square. So it is the denominator. So what happens? You get 1,96,200 Newton per meter square. So Pn, you express it in meters of oil. So it is Pn by oil is equal to Pn by 8829, that is equal to, sorry, this is Pm. Okay, Pn by oil is equal to Pn by 8829 Newton per meter square, that is equal to Pm by gamma oil plus 1.5. So you get this much meter of oil. So this can be converted into Newton per meter square and then into kilogram force per centimeter square in the reverse direction. So you get 2.135 kgf per centimeter square is the reading that will be shown by the pressure gauge when it is directly attached to point N. Okay. So another problem, example 11, is again on inverted U-tube manometer. A manometer is used to measure the pressure difference between 2 points in a pipe. Here the pipe is inclined. The pipe carries water. Above the water in the manometer is air. So the manometer does not use any liquid, only air is present, which is pressurized. When the pressures are transmitted through the limbs, the manometer readings are Z1 equal to 100 millimeters. Z1 equal to 100 millimeters. This is equal to 100 millimeters. Z2 equal to 250 millimeters. And H is equal to 90 millimeters. This is 90 millimeters. What is the value of PA minus PB in Newton per meter square? So you are asked to find out the pressure difference between A and B in Newton per meter square. So let the pressure at A be PA Newton per meter square. So again we start from A, go via the left limb, then the right limb, and then end up at B in developing the manometric equation stage by stage. Then pressure intensity at C. Where is C? C is the surface of liquid in the left limb connected to point A. So pressure at C will be less than PA. So PC is equal to PA minus, what is it you have? AC is Z1. Z1 is the column of liquid of, that is water, column of water. because water is flowing through the pipeline. So 9810 is the specific weight of water multiplied by Z1 is given as 100 millimeters, that is 0.1 meter, 0.1 meter. So you get PA minus 981. Then we go to D dash. What is D dash? D dash is a point, D dash is a point in the left limb which is in the same level as that of D. D marks the surface of water in the right limb connected to point B. So D dash, what is pressure at D dash? Pressure at D dash is equal to pressure at C minus the pressure due to the air column in CD dash. Okay. Again we can neglect the pressure due to air column because air has got a very less specific weight and therefore the pressure due to the influence of that air column is very small, it can be neglected. So pressure at D dash is equal to pressure at C. So PD is equal to PC, that is PA minus 981. So pressure at D is equal to pressure at D dash because D and D dash lie in the same horizontal plane. Then you come to C dash. Where is C dash? C dash is in line with C. C is the level of liquid in the left limb connected to A. So C dash. What is C dash? Pressure at D minus, plus H, because when you are going down the pressure increases. So pressure at C dash will be greater than pressure at D. By how much? By H meters of water column. So pressure at C dash is equal to pressure at D plus gamma W into H. So what is H is given as 90 millimeters, that is 0.09 meter. So you get this much. Then pressure at B, then ultimately we are ending up at B, this point. So pressure at B will be greater than pressure at C dash. What is pressure at B? B is equal to pressure at C dash plus gamma W into Z2. Z2 is given as 250 millimeters, that is 0.25 meter. So pressure at C, PA plus 98 plus this much. This is PA minus 98, this is PA minus 98, this is correct. Please change this positive sign, this is PA minus 98, that is pressure at C. So you get ultimately PB minus PA is 2355 Newton per meter square, that is PA minus PB is equal to minus 2355 Newton per meter square. So if you get PA minus PB equal to negative sign, what this indicates, we assume that the flow direction is from A to B. It's not like that. In fact, the pressure at A is lower than pressure at B. That means the flow direction assumed is wrong. This is wrong. In fact, the correct flow direction is this one. So we assume that the flow was from A to B and we started from A and developed the manometric equation. And when we worked out PA minus PB, we are getting it as minus 2355 Newton per meter square. That means the pressure at A is less than pressure at B. That means what? The flow direction is not from A to B, it is from B to A. That is in the upward direction. This is the flow direction. We will go to the next problem. Again another problem on inverted U-tube manometer, wherein we come across a pipeline with changing cross section. The figure below shows an inverted U-tube manometer with oil of density 800 kg per meter cube. Above the pipe liquid which is water. The pipeline is horizontal. What is the value of PA minus PB? So here we have got a manometric liquid. The manometric liquid is oil of density 800 kg per meter cube, which is lesser than the specific weight of liquid that is flowing through the pipeline, which is water. So you are asked to find out the pressure difference between the gauge points A and B. If the manometer readings are the same but the oil is replaced by air, instead of oil you have got only air, what is PA minus PB now? So again we express the pressures as intensities, that is Newton per meter square. So pressure at A is PA Newton per meter square. Then pressure at C. So where is C? C marks the interface of water and the overlying oil in the left limb. Okay. So, from A to C you have this is water, this is water, this is water column. So, Pz is equal to Pa minus gamma W into 0.28. This is 0.28, 280 millimeters, therefore 0.28 meter, 0.28 meter. Okay, Pa minus 2747 you get. Then pressure at D dash. What is D dash? D dash is a point in the left limb such that it is taken at the same level as D, which is in the right limb, and D marks the interface of underlying water and the overlying oil. So, D dash. What is D dash? C to D dash, what is it you have? This is oil. The column C D dash is oil. We are expressing pressures as intensity, that is Newton per meter square. So, pressure at D dash is equal to pressure at C minus pressure due to oil column C D dash. So, pressure at C is Pa minus 2747 minus gamma oil into the column C D dash. So, what is C D dash? C D dash, this is 430, this is 280. So, C D dash, the column C D dash is equal to BD, the column BD minus column AC. What is BD? 430 millimeters, this is this one, minus 280, this 280 millimeters. So, this comes to 150 millimeters. Okay. So, this is 0.15 meter. So, you get pressure at D dash is equal to Pa minus 3924, of course, this will be Newton per meter square. Then pressure at D. So, D is a point in the same horizontal plane as that of D dash. So, the pressures will be equal, pressure at D will be equal to pressure at D dash, okay, since D and D dash lie in the same horizontal plane. So, PD is equal to Pa minus 3924. Then you are coming down to B, the next gauge point. So, B will be greater than PD because B is lower than D. The pressure increases with decrease in elevation or the pressure increases with depth. So, pressure at B will be pressure at D plus what is it you have in this column 430 millimeters, it is it is water. So, gamma W into 0.43 meters of water. So, you get Pa plus 294. So, Pb minus Pa is equal to 294 Newton per meter square. Okay, this is the answer for the first part of the problem. The second problem, what is the second problem? If the manometer readings are the same, there is no change, same thing 280, 430, but you do not have oil, this oil is absent. So, here there is no oil, here you have air, there is no oil. So, this is not there. So, what will be Pa minus or Pb minus Pa, that is what is asked. So, let us now consider the case where oil is replaced by air and the other things they remain the same. The deflections of water in the inverted U tube manometer is the same. So, pressure at A, Pa Newton per meter square, pressure at C this much, then pressure at D dash, again you are neglecting the air column in CD. So, pressure at D dash is equal to pressure at C minus 2747, then pressure at D is equal to pressure at D dash because D and D dash lie in the same horizontal plane. So, there is no difference up to this point. Then pressure at B will be pressure at, this is instead of oil you have air column here C D dash, right. So, pressure at D dash will be pressure at C only because we are neglecting the air column. So, you can go through the steps. So, pressure at B will be pressure at D plus specific weight of water into 0.43. So, 0.43 is this column. So, you get this much. So PA minus PB is equal to minus 1471 Newton per meter square, or PB minus PA is equal to 1471 Newton per meter square. So pressure at B is more than pressure at A, or the flow direction is from B to A. Okay. So the next one, we are moving into U-tube differential manometer. The third category of differential manometers. The first one we saw 2 piezometer manometer. The second one, inverted U-tube manometer for measurement of small pressure differences. So here the U-tube differential manometer, the construction, it consists of a glass tube bent in the shape of English alphabet U. The two ends of the U-tube manometer are connected to the gauge points. So here the gauge points are A and B, say. Again is a pipeline which is conveying a fluid of specific gravity S, say from A to B. The flow direction is from A to B. So A and B are the gauge points. These are the gauge points. It is required to find the pressure difference between, that is PA minus PB is required. This is what is required to be measured. So this is the manometric liquid. This is the manometric liquid. Say for example mercury of specific gravity 13.6. So which is the manometric liquid. So here in the inverted U-tube, if you are using a manometric liquid, the manometric liquid should have a density lighter than the density of fluid that is flowing through the pipeline. So whereas in the case of U-tube manometer, you should have a liquid which is heavier than the liquid flowing in the pipeline. And also the manometric liquids should be immiscible, whether it is inverted or U-tube differential manometer, the manometric liquid should be immiscible with the liquid flowing in the pipeline. They should not mix with each other. So before measurement, the level of manometric liquid in the two limbs of the manometer should be made to lie in the same horizontal plane. So initially, so the level of mercury will be, say, here. That is initially, say it is somewhere here. So in fact E is here, somewhere here. This is A and this is B. The flow direction is from A to B. So before measurement, the level of manometric liquid in the two limbs of the manometer should be made to lie in the same horizontal line by releasing the air cocks. When the two limbs of the U-tube manometer are connected to the gauge points A and B, because of the pressure of the flowing fluid, the level of mercury in the two limbs will be pushed down. So because pressure at A will be transmitted, the liquid will flow through the left limb. Similarly here the liquid will flow through the right limb. So what will be the tendency of these two pressures? The tendency of these two pressures is to push the mercury column down in both the limbs. But as the pressure at A will be higher than the pressure at B, as the pressure at A is higher than the pressure at B, the pressure exerted in the left limb on mercury will be higher than the pressure exerted by the liquid on mercury in the right limb. Therefore, the mercury level will be pushed farther in the left limb than, and there will be a corresponding rise in the level of manometric liquid in the right limb. So corresponding to the difference in pressure intensities BA and PB at points A and B respectively, the levels of mercury will get displaced through a distance x. So this is the displacement of mercury in the, or deflection of manometric liquid or mercury in the U-tube manometer. So by measuring this difference in levels of the manometric liquid, the pressure difference may be computed as below. So we can develop the manometric equation step by step. We can start at A and end at B. So let S be the specific gravity of the liquid flowing through the pipeline, Sm be the specific gravity of the manometric liquid. So let us develop the pressure equation starting from point A in pipeline. Let us express all pressure quantities in terms of equivalent columns of liquid of specific gravity S. So here we are expressing in terms of equivalent column of specific gravity S. So let pressure get at AB PA by gamma W S. So gamma W is specific weight of water. S is the specific gravity of fluid which is flowing through the pipeline. Pa is the pressure intensity at A. Then pressure here at C will be this is C in fact, sorry, this is C. Pressure head at A plus this column. What is this column? From A to C it is Y plus X. Y plus X. Again Y plus X, what you have in this column? It is only the liquid of specific gravity S flowing through the, or fluid of specific gravity S flowing through the pipeline. So Y plus X meters of liquid of specific gravity S. So Pa by gamma W S plus Y plus X meters of liquid of specific gravity S. Then F, this is F. So pressure gradient F is equal to pressure gradient C, because C and F lie in the same horizontal plane. So the same expression holds good for pressure gradient F also. Then pressure gradient D. So from F you are going up to D. So pressure at D will be less than pressure at F, because D is above F. So pressure head at F minus the pressure head due to, or pressure due to column of manometric liquid or specific gravity Sm. So how we are expressing? We are expressing all pressures in terms of pressure head, that is equivalent column of fluid or specific gravity S. So this manometric liquid, column of manometric liquid has to be converted into equivalent column of fluid or specific gravity S using say S into say H is equal to Sm into X. So we want H is equal to Sm by S into X, Sm by X into X. This is the say meters of fluid or liquid or specific gravity S. So you get substitute. Then you go to B. Pressure gradient B will be pressure gradient D minus, because PB will be less than PD as B is above D. So pressure gradient D, B is equal to pressure gradient D minus this column. What is column BD? BD is Y. Y meters of liquid of specific gravity S, or fluid of specific gravity S. So ultimately you get Pa by gamma WS minus Pb by gamma WS is equal to X into Sm by S minus X, that is X into Sm by S minus 1 meters of liquid of specific gravity S. So let us solve a problem here. A pipe containing water at 172 kilonewton per meter square connected by a differential manometer to another pipe 1.5 meters lower. So pipe 2 and pipe 1. Pipe 2 is lower than pipe 2 by 1.5 meters. That is this one. So here the pressure is given in pipe 1, 172 kilonewton per meter square. If the difference of height of two mercury columns of the manometer is equal to 75 millimeters. So mercury is a manometric liquid, the difference is 75 millimeters, this is 75 millimeters. What is the pressure in the lower pipe? So P2 is equal to how much? Specific gravity of mercury is given. This is in fact C. So, pressure intensity in pipe 1, that is 172 kilonewton per meter square, that is 172 multiplied by 10 power 3 Newton per meter square, because 1 kilonewton is 1000 Newton or 10 power 3 Newton. Pressure here in pipe 1 in meters of water, if you are expressing in meters of water, it is P1 by gamma W, that is this much. So, all pressure terms we express in meters of water. Then pressure here at point A, in fact this is B and this is A. So, A is the interface of overlying water and underlying mercury in the left column. So, pressure here at A is equal to pressure here in pipe 1 plus 1.5 meters is the difference between 1 and A. This is 1.5 meters. Then pressure here at B is equal to pressure at A plus Y. In fact, this is B. Sorry. So, B is here. So, this is A and B is pressure at A plus Y meters of water. Okay. Then pressure here at D, D is here. So, pressure here at D will be pressure here at B, this is D, this is B, this is A and this is D. So, A is a point which is in line with the center line of pipe 2. B is the interface of mercury and overlying water, and D is a point in the left limb in line with C, which marks the interface of underlying mercury and overlying water. As some of these markings are missing, the confusion has arisen, sorry for that. So, pressure at D will be pressure here at B plus what is you have in the column BD, it is 0.075 meters of mercury expressed in equal meters of water. So, 0.075 meters of mercury has to be converted into equal meters of water. So, SM by SW, you get this much. Then pressure at C, C and D are in the same plane. So, pressure head at C will be equal to pressure head at D. Then at E, what is E? E is a point in line with B. B marks the interface of underlying mercury and overlying water in the left limb. So, pressure head at E will be pressure head at C minus column of water in CE, that is 0.075 meters of water. Then pressure head in pipe 2, pressure head at E minus Y meters of water in column E to 2. So, you get 19.978 meters of water, which can be converted into pressure intensity as well as pressure shown by a commercial pressure gauge. So, I think with this we will end session, and we will continue with some more problems and also problems in competitive examinations in the next module. Thank you.